I didn't see you. Hi. No, I'm just joking. I definitely saw you. Some wise woman once told me yesterday that I use the I didn't see you there way too often, so I'll try not to do that. Okay, so here we go. We're going to do our last day of trying to represent adding and subtracting on the number, or adding and subtracting with negative numbers using a graphic representation or a manipulative. After today, if you're able to do it on your own, then you don't need to do these models anymore. If not, I'm going to tell you to use these models. All right, so we are going to be talking about using a chipboard or a chip model to represent adding and subtracting. We're going to go back to the old days before computers, which, to be honest with you, given how my computer's working today, sounds so much better. When we had accountants who had to write down in a ledger the amount of money a business has earned or lost. Now, back in that day, they used black ink to describe something that was positive, income. So income was always black. That's my alarm to make sure I wake up, but I'm awake. And the accountants used red ink if it was a negative, if it was an expense, or if they ended up losing money, if they had a negative profit. So you may have heard the phrase in the black or in the red. In the black simply meant that at the end of the day, when you totaled up your income and your expenses, the accountant was using black ink because you earned more money than you had to pay the same business. If you're in the red, it meant the accountant had to use red ink because you lost money for that day. So that's the origin of that phrase. So anyways, black is going to represent a positive one. Red is going to represent a negative one. So I have a really cool chipboard right here. And let's figure out what the value of it is. So we have 7 black chips. But what will 7 black chips represent in the context of this problem? Well, hold on a second. Can I borrow your red pen for a second?
Of course.
So I'm going to be working in the red here. So if I have this red, if I have these 7, that represents a positive 7. And does that look right? Yes, that looks okay. So then if I add 4 red chips to it, so that's adding -4. Well, here's the cool thing. We can pair these off. We can marry the black and the red. And if you marry the black and the red, the total value of the married couple is 0. Okay, that's not a social commentary, just bear with me here. So when I pair these up, these all equal 0 because +1 minus 1 is equal to 0. +1 minus 1 equals 0. +1 minus, you get the idea. So after I pair them off, what am I left with? Well, I'm left with, you can't see it, you're left with 3 black chips. Each black chip is worth +1, so therefore 7 plus -4 is equal to 3. And that's a positive 3. All right, well, let's try one more. Let's say we have -5. And so how do I represent -5? And we're going to represent -5 with 5 negative chips, 5 reds. So this time, let's add. So let's add 3. How about 2? Because that's how about I was right. So if I add 2 black chips, what is the value of this expression? Well, I'm going to pair off my pairs. So now that equals 0. And I'm left with 3 red chips. How much is each chip worth? It's worth -1. So I have a -3. So that's how I add on the chipboard, or chip model. Subtracting is very similar. Let's say I start with 7. Let's start with 6. 6 used to be my favorite number, but it's not anymore. So let's say I start with +6, and we want to subtract. How about 4? So I can use the chip model by taking 4 and removing them. What am I left with? Well, I'm left with 2. Now the tricky thing comes, let's say I start with 6. And I'm going to, this time, I'm going to subtract negative 4. So right now, tonight, what I want you to do, and this is super important for tomorrow's class, how do I subtract 4 negatives? How do I subtract 4 red chips? So tonight, while you're getting ready for school, I want you to think about that. How do I represent this problem on this chipboard? All right, I will see you tomorrow. Have a good evening. Bye.